Oh. Let's go. Do, 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 do. Ooh, I got Fleetwood Mac going now. Ray, did you make it in here? Yeah, you did. Do you have trouble logging in? Because like your name appears twice in my room, and it's really annoying.
Yeah.
Chew
My
with your mouth.
app doesn't work, so I have to join from the browser.
Ah, chew with your mouth closed. That's disgusting. It's just a joke. You're doing just fine. It's fine. All right, sports fans, let's go with the giddy up. Learn it, live it, love it. FaceTime with your peeps if you're having trouble. And we'll go over it here in just a sec. Okay, hold on. Hold on. Lisa in the house. All right, let's go. Manya,
Hi,
how you doing?
I'm great. How are you?
Good. Gabalicious, are you in the house?
Yeah. I'm
Hi,
here.
Gabby.
Hi.
Gabalicious. You probably don't like Gabalicious. I'll try and stop that. Oliver.
Okay.
I'm here.
Lisa, Will I am. I need to see your wonderful faces. Hi, Oliver. Severe.
Here.
Lauren.
Here.
Yasmin.
Here.
Grant.
Here.
Aiden.
Here.
Namir.
Here.
Lisa.
Hi.
Hi, Lisa. Hold on. Someone just rang the doorbell. Who's late? Oh, wait. There we go. All right. Boom, boom, boom. Boom, boom, boom. We did Aiden. Did Namir, we did Lisa. Zhengzhou.
I'm here.
Ray, we established. Zach.
Here.
Zach, okay. Let's see. Om.
Here.
Jason.
I'm here.
Helen.
Here.
Alessandro. Kevin.
Here.
Reggie. Is he still golfing?
Yeah.
Yeah.
Owen. You know what? I heard about Owen. Are you there? I see your square, Owen. I don't see you. There I am muted you. Are you there, Owen? There you are. All right. Ooh, you're in the House of Becker with Alessandro and Zachary. Who else is in the Becker household classroom? All right. Hey, stay out of trouble. You smell what I'm cooking? All right. Okay. If you guys want to work on the whiteboard, you're welcome to do that. Did I miss anybody? Okay. All right. Getting it done, picking it up, putting it down. Let me hide this. Okay, technical difficulties. All right. All right, let's give this a whirl. I'm going to go through it a bit. Multi-steps, lots to do. I took the liberty of drawing a line, boys and girls, right here. That is perpendicular to ray DB through point B. I'm going to call that, let's see, we'll call that line P and this line Q, just so we can refer to them. And we're being asked to find the Y-intercept, which would be about right there if my line is accurate, which of course it is. And so in order to do that, we need to write the equation of a line, boys and girls. And to write an equation of a line, we need a point on the line, which we have. Its point B is on our line, and that point is -2, 4. We also need the slope / gradient of the line. Gradient is IB, slope is not. I will use them interchangeably. Now, as I'm going through this, I can't see everybody while I'm yakking, so if you need some help, you gotta unmute yourself and ask a question. Please do that, okay? So I cannot find the slope and gradient of line P. That's the line that's the slope of the line that I need. But I can find the slope of the line that is perpendicular to it, right there, perpendicular. And we know, because we are outstanding mathematicians, that the slope of perpendicular lines are opposite reciprocals. Huh. So I'm going to find the slope of line Q first, and that is going to be, using my slope formula, 4 minus 0 over -2 minus 3, which is going to be -4/5, which means that the slope of line P will be opposite reciprocal of -4/5, which is 5/4. Any questions on that? So I'm going to find the equation of line P, and I have the point, which is -2, 4, or a point, and I have the gradient, which is 5/4. Now I'm going to use, there's a couple things you could do, but I'm going to go ahead and use point slope form, which is y minus y1 is equal to m over x minus x1, which, by the way, if you think about it, you don't have to write this down. This point slope form is just the slope formula manipulated, multiplying both sides by x minus x1. Another little tip here, boys and girls, if you are a note taker, some of you folks just write everything down and you're not thinking, you're just copying, okay? And if you're not able to think while you're copying, you know, you can copper if you want, it's fine. I would suggest you just pay attention, because I post the notes every single day. Your choice, whatever works for you. All right, so now we have y minus 4 from the point is equal to 5/4 times x minus a -2 is x plus 2. Okay, so we got two choices here. We could let x, the y-intercept is going to have the coordinate 0. That's what we're looking for, 0, y. Okay, so it's going to be 0, y. So we're going to go ahead and let x equal 0, solve for y. That's going to be our y-intercept. We could also just solve for y and put it in the form y equals mx plus b, right? And b is the y-intercept. We could do that. But I'm going to go with substituting in 0. I think that's a little bit zero. That's a little bit easier. Y minus 4 is equal to 5/4 times 0 plus 2, which of course is 2. So y minus 4 is going to equal to 5/4 times 2 is 10/4 or 5/2. I expect you to be able to add, subtract, multiply, and divide fractions without whining, without questioning. Just do it. 5/2 plus 4. Well, isn't 4 equal to 8/2? This is how you can do it in your head. 4 is equal to 8/2. 5/2 plus 8/2 is 13/2. Let's get a booyah. That is our y-intercept. Boom. Boom, chugga-lugga-lugga, boom, chugga-lugga-lugga, boom, chugga-lugga-lugga, boom. I am stopping. I am asking if there are any questions. We are done at 9:30 in this class today, so I need someone, if I don't remember, to stop us at 9:25 so you in classroom people can stop, sanitize. I'm waiting. I'm waiting. I'm waiting. I'm going to talk a lot today. I don't like to do that, but it's just the nature of what's going on since I gave you a bunch of questions and it's review time, so I'm going to go through them. I know it's hard to focus for a long time when a boring dude like me is like blah, 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 but hang in there, kids. We can get through it together. Stand up if you need to. Stretch your legs whenever you want.
Sir, can you explain to us once again how this equation of line works? Like y minus y1 equals m times x minus x1. How does y?
Okay, that's one of the forms of a line. It's the point slope form of a line. Ooh, that's a little cray-cray. Point slope form. Right there. Now, why does it work? Well, do you agree? Well, we're used to y2 minus y1 over x2 minus x1. I don't know who asked that question, but do you agree with that?
Yes.
Okay. Well, I'm just going to rewrite it as y minus y1. It's two different y's, right? It's the same thing. Here we're just using a 2 and a 1. Here we're using, I don't know, let's call it y sub 0, I guess, and y1 over x minus x1. That is an established formula, right, for the equation of a line. I'm sorry, to find the slope. Yes?
Yeah.
Okay. So if I clean this up just a little bit by multiplying both sides by x minus x1, Kapow theorem, Kapow, and I just turn this around a bit, put the m in front. And then the way I wrote it on the other page is this. So the equation of this line is based on the formula for the slope of a line, which has been proven before. I hope your mathematics teachers before showed you why this is true. Is that acceptable?
Yeah, I understood it.
Okay, but this is something you got to have in your back pocket along with y equals mx plus b, yes? For equations of lines, general equations of lines. Okay. All right, so take out the home fund 2. Let's just chat about that. Okay. And I'm just gonna chat through this. My hint was it's all about that base. About that base. About that base. I mean, that's pure poetry right there. Seriously. I wish I could write songs like that. I mean, it's inspiring. Whew. Okay. So, rules of exponents. I can rewrite 25 as 5 squared. I already have a base of 5 right here. I can rewrite 125 as 5 cubed, which I did. So I just rewrote, that's from here to here. Then, rules of exponents, a power to a power, we multiply. This becomes 5 to the 6a plus 2. Everything's cool with this one. 3 times a, 3a. Rules of exponents, same base. If we're multiplying, we add the exponents. 6a plus a, 7a. 2 minus 3, negatory 1. We're going to leave 3a alone. Nothing's happening to it. Rules of exponents, same base, dividing, you subtract the exponents. 7a minus 1 minus 3a is 4a minus 1. Booyah! Boo to the yah. Boo to the yah. The great thing about me not being able to hear you is I'm just assuming that you are laughing hysterically. Much better. Questions? All right, this next one, kids, there's a lot of different ways to go here. A lot of different ways. My way is not necessarily the best way. In fact, throughout the course, my way is not necessarily the best way. If you have a more efficient way, I want to hear about it. Now, not on this one, because there's just so many different ways that are totes legit. Probably about the same amount of effort as mine, unless, of course, you use your calculator. Our calculator can solve that system. I hope you know that. I'll show you, not today, though. So here we go. I shall tell you my thinking. First of all, those are the solutions I got. They are correct according to first period. I don't trust first period. You know why. Okay. But I'm fairly confident. Okay, so that's where we're headed. And I'm looking here, and I'm not capable of solving a 3x3 system. So I need to get it to a 2x2 system, meaning 2 variables, 2 equations. So I got to eliminate one of these variables. And I'm looking. And I look at equations 1 and 2 here, and I notice if I were to multiply equation 2 by 3, I would get a negative 3z here, and combined with a positive 3z, the z's are out, they are out, okay? So that's what I did. Took equation 1 and equation 2, rewrote them. Multiplied equation 2 by 3, all of it now. Distribute the 3 to get 9x minus 6y minus 3z equals city 6. Make sure you multiply both sides by 3. Otherwise, you are performing an illegal act, and I will send the mafia after you. The mafia is all about doing mathematics correctly. That's what I did this summer. I told you I was in a gang. Bring equation 1 over. I combine them like it's 1999. 2x, 9x, 11x. Negative y, negative 6y, negative 7y. Kapow, 3z minus 3z is 0. 10 and 66, the last time I checked, that is equal to 76. Booyah, booyah, booyah. I got my first equation. I need another one. So I'm looking for two different, let me rephrase that, a different pair of equations to stop, manipulate, and listen, where I can get rid of the z. And it looks to me like I can use equations 2 and 3, multiply equation 2 by -2, which would result in a positive 2z, combined with a negative 2z is 0. All right, so here's what I did down here. Brought equation 2 down, and I multiplied through by -2. Boom, -6x, positive 4y, positive 2z, -44. Bring the 3 over, or equation 3 over. Combine those two. I get -2x plus 7y equals -31. Booyah, booyah, booyah. I got myself two equations and two unknowns. Two unknowns being the x and the y. I'm going to pause and see if anybody wants me to explain anything that has happened thus far.
Can't you just combine all the equations so you eliminate 2?
My goodness, who said that? Severe?
Yeah.
I did not see that, sir. You could get X right away, couldn't you?
Yeah.
That's how dumb I am, Severe. You need a better teacher. I suggest you withdraw from the school, head round the corner to Windermere High School. Didn't see it. That would have saved us a whole lot of time. Does everybody see what Severe is saying? If I combine all of them, I would get 4, 5, 6, 7, 9x. -y, -2y, and positive 3y. 0. 3z minus z minus 2z, 0. So then I would get 9x equals 3245, and I would get x equals 5. Severe, where were you when I was writing this out? I think I made a severe mistake, Severe. Whoa, bet you haven't heard that one. I'll be here all year, folks. All right, well, you know what? You want to suffer, you do it my way. So I'm just going to continue, because a lot of times that won't work. This is a question from your Beltray midterm, and he was trying to help you out. Me, I don't like helping you. I mean, wait. All right, we'll continue this way. If you solve this system of equations by elimination, you get x equals 5 in a less efficient manner than Severe did. Once you know x equals 5, you can substitute it into one of these two equations. And by the way, let's take a time out. We substitute values in for variables. We replace variables with values. We do not plug them. We don't plug them in. You plug in an electrical cord into a socket. When you are writing your internal assessments as big boy and big girl IB students, you're not going to write plug in, because you will be escorted to prison, IB prison. I've been there, not good. So we replace x with 5 and we get y equals -3. Now that I have x and y, I can choose any one of my original 3 equations, replace x with 5, y with -3 like I did here. Boom, chugga-lugga-lugga, z equals -1. Severe, in all seriousness, thank you very much. I just didn't see it. Well done, sir. Wait a second, a male saw that. Ladies, what's going on? Gabriella, did you see it too? Okay. You're letting the male have a win. I get it. I get it. We appreciate it. On behalf of my gender, thank you. Questions from anybody? All right. So now we get to do some right triangle trigonometry. The accompanying diagram shows a flagpole that stands on level ground. Two cables R and S, here they are, R and S, are attached to the pole at a point 16 feet above the ground. It's already labeled for us, but if it's not, then you need to label it immediately. The combined length of the two cables is 50 feet. Immediately, this is the first thing I wrote. You should write R plus S is 50. If cable R is attached to the ground 12 feet from the base of the pole, boom, right here. Here's the attachment. What is the measure of the angle X to the nearest degree that cable S makes with the ground? So we're looking for X. The variable X, I'm not looking for drugs. Stop it. Stop it. Now, looky here. If I find R, I can get S because I know that R plus S equals 50. And this is a very rare thing that we're going to use here. It rarely comes up in mathematics. It's a little known theorem. I had to actually look it up. It's called the Pythagorean Theorem. Say it with me. Pythagorean Theorem. Hardly anybody knows it. All right. But we're going to use it right here. R squared equals 16 squared plus 12 squared. Boom, 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 boom. Now I put plus or minus 400 just to remind you, if we were only solving the equation, I need both solutions. But I know that R is a length, so it must be positive, so we take R equals 20. Time out, time out. Going to take a 30-second timeout, boys and girls.
Like a perfect right triangle, so you could just find R instantly.
You could, if you know, I thought about that, Severe. You don't have me on that one, but I just wanted to take the opportunity to do this, to do the plus or minus. I'll get back to that in a second, Severe. Where was I? Oh, you as elite mathematicians should know, must know your perfect squares through, are you ready? 25 squared. You should know them. 14 squared, 15 squared, 16 squared. 16 squared, 256. Yes? 24 squared, 496. You should know them. It makes your life so much easier. What Severe was saying is this is the multiple of a 3, 4, 5 triangle. 3, 4, 5. 3, 4, 5 triangle, meaning sides of length 3, 4, and 5. So if I see a triangle that has sides 3, 4, and 5, I know it's a right triangle. Well, 4 times 3 is 12. 4 times 4 is 16. And as long as I know those are the legs of the triangle, that's key, I know that the other side must be 4 times 5 or 20. So any multiple of 3, 4, 5 is a right triangle. Another famous right triangle, 5, 12, 13, that's second most popular. Probably third most popular, 7, 24, 25. Pythagorean triples is what we call those. All right, so now I have S. S must be 30. SOHCAHTOA from X, we've got opposite. This is the hypotenuse. That's big boy sine. I do inverse sine to find the angle, or arc sine. I don't know if you've heard that term. Inverse sine or arc sine, ARC. And to the nearest degree, I got 32 degrees. Questions? Okay, don't be afraid of that Pythagorean theorem, all right? It just comes up every so often, not very often at all, except in the next question. All right, so y is the length, is this length of this triangle. It's coming straight down, so it is a right triangle. We know that from here to here is 2 because the x coordinate is -2, so that means this length is 2. We know that this hypotenuse is 5 because the radius of the circle is 5, and this segment is a radius of the circle. Bing, bang, boom. Our good friend Pythagoras, y squared plus 2 squared is 5 squared. Again, I will post these. Okay. Any questions? This is prior knowledge. It was from your first semester, so it's not missed content or content you might not have gotten to from your second semester. Okay? So if you're a little rusty, maybe you get online, take a look at your old topics. Practice is all over the place. But it is my expectation and the expectation for this course that you're able to do things like 1 through 4. Okay, so we start off our year in the 10EL doing some geometry because of the PSAT coming up. We'd like to get you some geometry practice, good solid understanding to help you do well with that. And with geometry, of course, comes algebra as well. So that's why our first unit in our first module is Algebra Geometry Essentials. So let's go here. This is our the module section. That's where everything that is the hub of our course. Home Fund 3 is today, but part of Home Fund 3, the first instruction, don't do it now because we're going to do some stuff here in a second, is to click the link here for this geometry textbook that we're going to use for a little while. It'll take you to an online textbook, and then I want you to download it as a PDF. Using it online, it's not friendly. It's very unfriendly. You have to scroll. There's no way to get to a page immediately. Okay, and it's old. It's a PDF. So while you can get to chapters quickly, you can't get to pages quickly. Specific pages. Okay, so for example, right here is page 394. Okay. I am not, when I give you an assignment, I am not giving you the book page number. I am giving you the PDF page number. And I say that when I give the assignment, it says PDF page number. Okay. That way, if I say, all right, I need you to do page, I don't know, 521, you can just highlight there, 521, hit enter, and there you go. Everybody with me? I tried to come up with an algorithm. It doesn't work because they do things like 542A, 542B. So this is how we're going to roll for a little while. Okay, so I need to share the whole screen. Share screen. Oh, what's all this chat going on? I couldn't see it. Nice. Pun Patrol. You still on the Home Fund page instead of Canvas. Oh, I'm so sorry. Thank you. Thank you. I did it, didn't I? Let me show you that again. I don't always have my chat up because my window's totes crowded with attendance and all that. So sorry. All right, so Canvas page. Here's the geometry textbook. click, download. Hey, pipe in when I do that. Don't chat, pipe in, say, hey, Mr. B, you're a loser, all right? You're a loser, we can't see. All right, so what I was saying is the book page 545 does not match the PDF page, right? So I can't assign by book page number because you can't get to it easily with this form of the PDF. So if I say PDF page, I don't know, 327, you just type that in there, enter, and it'll go to the correct page. Okay. And again, in the home fun assignment, I say PDF page number. I am not referring to the book page number, the PDF page number. Is that better? Okay, sorry. Okay, so back to here. We're talking circles, boys and girls. I'm not going to tell you what a center, radius, diameter of a circle is. I'm just not. But I put these in the notes. It's also part of your home fun to kind of go through the chapter, the geometry book, and look at things you don't know. I am going to talk briefly. A chord is a line segment whose endpoints are on the circle. So PS is a chord. RP is also a chord, but it's a special chord since it goes through the center. We call it a diameter. Isn't that crazy? I know, Namir, right? Maybe you haven't heard of secant. Secant. When I was little, I used to play hide and secant. Actually, I still play. Secant. A secant is a line or a line segment that intersects a circle in two places. A tangent intersects a circle in exactly one place, or a curve, but we're talking circles, so I'm saying circle. I want to show you a couple properties of tangents that are theorems that are in the book. You could do this on your calculator, but it would take a while by hand unless you have the software on here. So just watch for a second. I'm going to draw myself a circle. Boom, boom. Okay. And I'm going to draw a tangent line, tangent. Boom, 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 boom. Okay, and I'll just grab that and make it a little bit longer, whatever. So we got a tangent line. I could move it all around if I wanted to. That's how crazy I am. Okay, now I'm going to draw a radius from the center to the point of tangency. The point where the line is tangent, that's called the point of tangency. Very important term there. Points and lines. Segment, and this segment is going to be a radius. What just happened? Radius of the circle. And I want you to look at the relationship between the radius and the tangent line or line segment. And hopefully you kind of see what I'm talking about. If not, I'm going to show you because I'm going to measure an angle. It's 90 degrees. And the lesson we just learned is that a radius drawn to a point of tangency is perpendicular to the tangent line or the line segment, no matter the size of the circle or where the tangent line is. Look at that. The angle just doesn't change. Ooh, it's like one of those rides. You know, when they have the fair, it's that pirate ship ride, otherwise known as the projectile vomit. That one. All right. That's one theorem comes to play all the time, and they don't tell you. They just say it's a radius drawn to a point of tangency or whatever. Okay, the other thing is, if I have an external point and I draw tangents from that point, two tangents, the line segments are the same length. I've asked the calculator to measure them for us, because I can grab this point and move that, and if you look, the measurements remain the same. See that? I can move it all around, it remains the same. I can grab this circle, make it bigger. Line segments, congruent, remain the same. Okay, so that's another theorem. And I laid all that out. We're gonna have to stop, I think, right? Because we're out at 9:30, is that right? Is 9:30 our time? Okay. Have a couple examples. The solutions are worked out in the book. This is just saying, is this a tangent line? And the answer is yes, because this is a right triangle, which means this is perpendicular. And then there's another example, you know, the external tangent, solve for x. Well, this has to be equal to this. So that's a simple thing. All right, so kiddos, you, let's see. Okay, so you people in class, stop, sanitize. Out of class, you're free to leave class. I'll hang out for questions until 9:30. Have a great 3-day weekend. I'm so glad the administration decided to give you a 3-day weekend. Isn't that awesome? Woo! And we'll see you back, all right? Check Canvas, do your assignments. Stay out of prison. Lauren, stay out of prison. You hear me? Yeah, exactly. Oh, you're used to that. Hands up. I see. I see. All right. Be good, kids.
Bye, Mr. Becker. Thank you.
You're welcome. Bye.